So consider an object in is speeding up along a straight line path. Yes, as I explained here. What is velocity change? So as I said, put them side by side so the uh, tails are coincide. Then after that, draw a directional line from initial to the final, and it is going to be delta V. If you look at delta V in here, you will see that delta V direction and direction of the motion of the object are the same. Yani this object is speeding up. So then you can say that if delta V is in the same direction of the motion, if delta V is in the same direction of the motion, the object must be speeding up. So if velocity changes like this, can I get acceleration? Yes, I can, because I know the definition of acceleration. I know acceleration is defined as delta V over delta t. This is definition of acceleration. If you divide a vector by a scalar, you get another vector. But these two vectors are always in the same direction. Or later we will learn, if you multiply a vector with a scalar, with the number, again these two vectors will be in the same direction. That is why delta V and acceleration are always in the same direction. That's why. So if the delta V is from left to right, acceleration of this object also must be from left to right in this direction. Acceleration. All right, this is how we get direction of acceleration. If you knew about delta V's direction, which means in fact you know about direction of the acceleration. Or if you know about direction of acceleration, which means you know about direction of delta V. And one last quantity. If this object is speeding up, how can you speed on one object? You should apply a force, is it? Without force, is it possible to change the velocity? No. So then, question. What is direction of the force acting on this object? What is the direction of force acting on this object which causes this object to speeding up? Again, we will use the equation of physics. Most probably you remember this equation. Force is equal to mass times acceleration. And then this equation also saying you that if you multiply a vector quantity with a scalar, because mass is a scalar, so you will get another vector, and these two vectors also will be always in the same direction. That's why. So force acting on this object must be in the same direction of acceleration. Then this is delta V. This is acceleration. The force acting on the object also must be in the same direction of acceleration, also must be to the right. So then I can say that this sentence is very valuable sentence, not only about section 3, chapter 1. We will talk about this in chapter 3, section 1. Force, acceleration, and delta V are always in the same direction. There is no exception. Force, net force acting on an object, acceleration of an object, and change in velocity of an object always in the same direction. A billiard ball is moving towards a wall and strikes the wall and reflects. So this is the type. This is normal about that chapter you studied in the 11th grade. Consider a billiard ball is moving and then colliding on the wall elastically. What does elastic collision mean? The ball does not lose energy. Its kinetic energy is conserved, which means speed of this ball will be the same. In here, after reflection, both speed will be the same. But velocities, are they the same? No, because initially the ball is moving to the right, but after reflection, it's moving down to the page. So velocities are not the same. Speeds are the same as a scalar quantity. Give number, random number. In here, say 10 meters per second. In here is also 10 meters per second because question says elastic collision. Billiard balls are generally making elastic collisions with the wall. So then reflects with the same speed, but direction of motion changed. Because direction of motion changed, there must be a delta V. Delta V must have a direction. So question is asking you, draw delta V's direction, acceleration direction, and force vectors as the ball reflects from the wall. When the ball reflects from the wall, draw delta V, A, and F. So again, I'm going to use the same method. What I said that put these two vectors, initial and final velocity vectors, so that their tails coincide. This is initial vector. I never changed direction of them. This is initial. And then put the final. So then look at here. Their tails are coincide. They coincide or not? Yes. Then draw a directional line from any tip of the initial vector to the tip of the final vector. So this is direction of delta V. When this ball strikes to the wall and reflects, delta V is not in the direction of VI, not in the direction of VF. It is at the angle, at some angle to this VI and VF. And we got velocity change and then get acceleration. This ball also gains an acceleration because of the change in direction. So let's apply the Newton's definition of acceleration. What is definition of acceleration? Delta V divided by delta T is A. And always A and delta V are in the same direction. That's why acceleration of the ball as it reflects from the wall will be in that direction, in the same direction of delta V. And of course, something must cause this object to change direction. There must be a force acting on this object. So that force is the force applied by the wall. This wall must act a force on this ball to reflect, to make it reflecting. So let's get the force. Use the second law of motion. Force is what? Mass times acceleration. So we know always force and acceleration are in the same direction, which means this wall is applying a force in the same direction of acceleration, in the same direction of delta V. So a force acts on this ball by the wall to reflect it in that direction. So as you see, you don't need to think about so much. Descartes says that if you know maths, you can answer whole questions. So this, if you are good at vectors, it is not difficult to solve the problems about the physics. Consider that a car is moving in a circular path with constant tangential speed. Draw the vectors of delta V and acceleration of the car at an instant in the circle. Yes, now let's go back. So you see how easy to find delta V and acceleration if you are good at vectors. So I'm going to choose two positions again. In here, first position of the car. In here, second position of the car. I'm going to give that. This is the initial velocity. This is the final velocity. I will compare what is happening, how velocity is changing from here to there. I'm going to try to get it. Same way. So locate two vectors so that their tails coincide. You see that their tails coincide? Yes. Did I change the direction? Never. V initial, V final, V final. And draw a directional line from tip of the initial to the tip of the final. You see delta V is pointing where? To the center. Didn't we say yesterday delta V must point to center? Yes, it is. This is not just information. This is mathematical result. So if you do an operation on vectors, you will see that delta V is always pointing to center of the circle. And what about acceleration? Use definition of acceleration. What is the definition of acceleration? Delta V over delta T. So if delta V is pointing to center, this equation says you acceleration of the car at that point also must be in the same direction of delta V, which is defined in this section 2 as centripetal acceleration. It's pointing the center of the circle. You can choose any other 2 points. I will choose 2 other points. Again, same car, but this time I will choose initial vector here. This is the initial vector. This is the final vector. So I will try to find how velocity is changing from this point to that point. Again, I will apply the rule. Draw initial vector. Yes, I draw. Draw final vector so that its tail is, their tails are, their tips are coincide. Draw a directional line from initial to final. As you see, delta V again pointing the center of the circle. And if delta V is pointing the center of the circle, according to the definition of acceleration, acceleration also must point the center of the circle, which is defined as centripetal acceleration. So as you see, if you are good at maths, physics is not so hard. If you know about the principles, about how to add the vectors, how to subtract the vectors, if you know them, so you can get easily without thinking about, just follow the maths.